It is a continuation of my previous video where we were trying to understand the internal execution of a Python code, and we have already discussed up to compiler. In this video we will start from virtual machine. As the name suggests, virtual machine is something which is not present physically, or it is a virtualization of an actual computer. It is a software which is able to give you the feel of a separate computer in an app window. Or in other words, we can say it gives us the separate execution environment for different program in the host machine. Now the question is, what is the role of a virtual computer in our topic? Actually, we have seen that after compilation the machine code or the sequence of zeros and ones is generated, which can be executed by the processor. Now after the compilation, if we get a code which is different from the machine code, then the processor cannot able to execute that code. So here virtual machine comes into picture, which is going to take this code and translate it into the machine code for the system. Now coming to the working of an interpreter, an alternative to a compiler is a program called an interpreter. In case of a compiler, we have seen that after compilation, it will directly create the executable machine code. But in case of an interpreter, rather than converting the source code directly into machine code, it will generate an intermediate code or the bytecode. And then this bytecode is further interpreted by an interpreter, which will create the machine code for the target machine. Now note that if this compiler is installed on machine 1, then this generated machine code is only executable on machine 1. And similarly, if this interpreter is installed on machine 1, then also the generated machine code is only executable on machine 1. So we can say that this highlighted portion is machine dependent. Then where is the difference between an interpreter and a compiler? The difference can be noticed in post-compilation code. After compilation, we have got an intermediate code or the bytecode, and this code is machine independent. For example, if we have three different systems, and if you run the same code on these systems, then the created machine code are different from each other, and also the interpreter which is installed on these systems are different. But each of them will create a same bytecode after compilation. Now this bytecode can be run on different systems. The following animation will help you for your better understanding. After writing the source code, it will get compiled by a compiler, and it will create a bytecode, which is further interpreted by an interpreter, and ultimately it will generate the machine code, which will get executed by the target machine, and it will give the output. Now the question is why we need an intermediate compilation stage, and also is it mandatory or not? A strictly interpreted language is possible, but it is slow because an interpreter spends a lot of time for analyzing the string of characters to figure out what they mean. A compiler translates the source code in some kind of data structure which represents the source code in more convenient way. Rather than stepping through a string of characters, it steps through a data structure, which is much faster to operate on. But still, interpreted languages are slower than compiler-based language, because in interpreted language, they involved an extra step where it generates a bytecode and then translate it in machine code. Now we will conclude some points about bytecode, like bytecode is the intermediate code. It is understood by the virtual machine, not the actual machine. It makes the programming language platform independent. Now finally coming to our main topic, that is the internal execution of a Python code. Python is usually called an interpreted language. Although compilation is one of the steps, the source code with .py extension will be first compiled by the compiler, and it will create a .pic file, which is called bytecode. Now this bytecode is further interpreted by the Python virtual machine, which is a part of our Python system, and it will translate the bytecode into the machine code, and then the CPU will execute the code. As a result, it will generate the output. Before going to finish this session, let me conclude some points. Python is machine independent language, but it is Python virtual machine dependent. We can run a Python bytecode on any machine, but PVM should be installed on that machine. Next is, Python is usually called an interpreted language, but also there exists a compilation stage.